trying to centralize them and make them more standard, which has been very challenging.
Hello guys, welcome at our next talk. And here I would like to present Amador with his talk about testing framework internals.
Okay, thank you. Hello guys, good afternoon. Thank you for coming by. My name's Amador Paim. I work for Red Hat as software engineer, and I work inside the virtualization team in the testing framework team. And I'm here today to talk a little bit about the testing framework that we are investing a lot of effort in it. And in this presentation specifically, we will be approaching the testing framework, looking to the internals, to the internal APIs and internal layers. So the goal here is to show you how we approached some challenges that we had during the development of this testing framework, and also show you how the testing framework that we are using in our team and in some teams inside and outside Red Hat, how he works from inside, so you can know the project, know how it works, probably get involved some way, helping with using it or helping to develop it. So let's get started. The testing framework that we will mention here is called Avocado. Do you guys know Avocado testing framework already? Yeah, some of you, that's nice, more or less. Okay. What's Avocado? Avocado is a set of tools and libraries, and the goal is to help with automated testing. Native tests are written in Python. Actually, Avocado itself is written in Python, but any executable can serve as a test for Avocado, so it's a generic testing framework. It was mainly designed to give a common ground, a bridge between QA and developers. So both groups, both teams can have access to the same tools and the same way to test the software that they are working on. And that was probably the main goal of the project since the beginning. One of the components of this testing framework is the test runner itself. With the test runner, we'll have automated logging, sysinfo collection, nice user interface, output format. So you can, with this test runner, have a lot of features without having to use the Avocado API itself. So the test runner is powerful by itself without needing to use the API. We have the APIs, we have the libraries. Here, it's just an example of a test that was written using the Avocado test and some Avocado utils as well. You can see here we are importing the test API here. Here we have our test class, our setup phase, test phase. And here we are already using some features from the test API itself. Also, we are using some features from the utils library as well. Just a quick example so you can see how an Avocado test using the Avocado API would look like. Some other components. Another important part of Avocado are the plugins. We have a bunch of them. Almost everything in Avocado is a plugin. We have Avocado VT plugin, which is a wrapper plugin to run the virt tests that were used in virt tests and auto tests before, to run them inside Avocado. We have HTML plugin, remote run, a bunch of them. Avocado is modular, so you can create plugins for almost everything. So you can plug them in Avocado and use it. So let's talk about the internals of Avocado, the internal APIs, the internal layers. This is a general architecture of Avocado itself. Here we have a job. And from this job, we will interact with all those layers here. The goal here in this presentation is to go through every layer we have here until we have the final test results here being published by the results plugins. So the first one, test resolver. In Avocado, we have the first step that's executed by a job is calling this test result. This test resolver, sorry. The test resolver will be in charge to receive the test references. If you take a look in this Avocado command line here, you can see that we are informing to this Avocado execution, to this job, what are our references. Here they are files, but we call it in Avocado test references. And out of these test references, the goal of this test resolver is to create a test suite that will be used in the next steps. And how the resolver can get this test reference and transform them in a test suite. Job will call this internal method called make test suite. The steps here are load the plugins. So we have in this resolver some different plugins that can be used to resolve the reference differently depending on the needs that given plugin has. The main plugin we have is the file loader. I will talk a little bit how the file loader will transform a test reference in something that's useful afterwards. This test resolver will receive just a list of the references that were informed in this command line here. This is all the test resolver will get from Avocado, from the job. There is a filter phase here. Currently, we can filter tests by tags. You can, inside your test method, create doc strings with tags, specific tags, and these tags can be used to filter tests to include a set of tests in your job. But the main point here is to create this test suite that can be used back by the job itself. And this is how the test suite looks like. This is the return from the test resolver to the job itself. So out of those test references up there, we created this test suite and in what's present in test suite. Here we have the class name, we have the method name, the test function itself, the module path, and also this name that's used to identify that test inside Avocado. If you take a look, we have only 3 files or 3 references up here, and we have 4 elements in this test suite. That's possible because in this test module here, my test 01, we had actually 2 tests defined, 2 test methods inside that test class. So we have the same reference here for the same module, but we have different functions, different method names coming from this file here. So this is the product of the test resolve that will be received back by the job. Now, talking about how our file loader can identify that a test is using or not the Avocado API to test something. Well, as we don't preload the code itself, we just try to make some static analysis in the code itself. And based on that analysis of the code, we can determine if the code is using or not the Avocado API. So we have some rules. If the test module has this Avocado, from Avocado import test, and if we have a class that inherits from Avocado test API, then it's probably an instrumented test, what means that it will be using the Avocado API. Different form of identify Avocado instrumented tests. If you are using just import Avocado, we will look for a class that looks like this. Or if you are not inheriting directly from Avocado, you have to flag that your class is actually using Avocado API. And if it's not an Avocado instrumented test and it's executable, then we consider it a simple test, which means that it will be just executed as a process in the system that you are running your test. And this is an example of the list command. The list command will just trigger the test resolver to discover what are the tests that are present in this test reference that you are informing there. Okay, once we have the test suite, it's time to call the varianter. The varianter in Avocado is a feature that allows you to create different variants of the same test. The goal here is to execute a given test as many times as you have different parameters to inject in that test, and then you can test different scenarios with the same code. This variant here, we will use YAML files. So you can define in your YAML files the parameters that you want to feed your tests with. And then afterwards, when the time to call the test runner comes, you will have multiple combinations of parameters to inject in the test. So you don't need to write multiple times the same test. You just need to write it once and create different variants of parameters that will be injected in that test. Job calls this method varianter, this module varianter, and it will parse the YAML files, possible injecting data. It's an advanced feature of the varianter to inject data in the resulting tree. And it will return the varianter object containing the multiplex, we call it mux tree. It's this object that contains a tree with all variants that can be used by the test afterwards. Okay, this is how a YAML file that's providing parameters to Avocado looks like. You can define, for example, CPU-C flags with three different values here. And you put this flag here to tell varianter that it has to actually create different combinations out of all of those parameters here. So the first time your test will be executed, it will have access to a combination of all those parameters. The second time, the test will have access to a different set of parameters out of this file. So in this example, we have 2 times 2 times 2 times 3 different combinations. So we have 24 different variants that will be used to feed your test that will be executed 24 times. Here, just the first 3 variants created out of that file. There's no enough space to put them all, but you can see that in first variants, you have these 4 values for those keys. In the second variant, you have just these changing here. In the third variant, we have the same systemd as in the first one, but now it's with a different value for disk type, and so on. And this is just to prove that out of that file, we will create this tree, and any test that is informed here in the command line using that YAML file, it will be executed 24 times, each time having access to a different set of parameters. Okay, next step for the job is the job data recorder. The goal of this feature in Avocado is to keep data, actually machine-readable data, that can be used for different features afterwards, after the job finishes. Right now, it's being used only by the replay and diff features. Those are two features from Avocado that will use this machine-readable job data to create something else, to provide something else to the users. For example, with the diff, you can compare two different jobs in several aspects. I have here an example of the diff feature being used. I'm informing here two job IDs. It could be the job results directory as well. You don't have to remember or to keep the job IDs. You can just put the path for a given job result directory and a path for another job result directory. It will compare several aspects of those two jobs using that data that was recorded by the job data recorder. So this is just an example of two jobs with different total time, different test results, different variants, difference also in sysinfo information. We consider each of these parts as a section, so you can show only one or other section depending on your depending on the information you're looking for. Okay, so after job data recorder, we have the test runner. Here, we already have the test suite from the resolver. We already have the MUX tree from the varianter, and we will merge them together and create the test, run the test itself. Job will call make test runner. Test runner will be selected. By default, we use the local test runner, which what means that your test will be executed locally in the same machine that the command line is being executed. But we also have remote, VM, Docker, different test runners, and those are the test runners that can execute your set of tests, your job entirely in a different host and not in the same host that you're using to create the command line. Job will call test runner. After selecting what test runner will be used, we just call the run suite method, and the run suite will receive the test suite, as I said before, and the MUX tree object, so the test runner can merge them together. The test runner will loop the test suite, and for every element that's present in the test suite, you remember the test suite, that big guy before? For every element that we have there, we will loop all the variants that we have in the multiplexing, and we will execute, you merge them together and pass for a test class, so the test class can actually execute the test from there. And this is what the test class gets from the test runner. You might notice that we have here some information coming from the test suite, and we have also the parameters coming from that specific variant that we are using at that point. The test class will receive this guy here, and based on this guy, it will load the module. It will look for the test class, it will look for the test method name, and will execute the test itself. This is the same test factory. We call this information here together. We call this test factory for the test class, and this is the test factory for a simple test. It's simpler than the previous one because it's not using the Avocado API. So what we need here are the parameters, because even simple tests can have access for those parameters. We need here the name, of course, the base log dir the same way, and only the simple test class that's already instantiated since the resolver phase. And this instance of the simple test class will just execute the command itself. Whatever command you defined as a simple test, it will be just executed. And that's making what I just said more explicit. We have for instrumented tests, we will create a fork, so the tests are executed in a different process, not in the same process as the Avocado main process. So we have these isolated results for the test itself. At this point, we will load the modules from the tests that are specified by the test writer. We will run the setup, the test method, and then the teardown. It's a behavior that's well known, like unit tests has something like that. So for the test writer, this is what you need to create, but all of that stuff are happening behind internally in Avocado. If it's a simple test, if it's not using Avocado API, the simple test class will just call the Avocado utils process and use the method run to execute the command. Either case, it will be a different process. It will be not executed in the same Avocado main process. Okay, and how can test writers have access to the parameters that were informed using YAML files and came all the way through the stack until arriving the test itself? If you are using instrumented tests, you can use the API self params get and tell what's the key you're looking for, and then this will return the value of that key as specified in your YAML file. If you are using simple tests, you still can have access to those variables, but in this case, you have to use environment variables. We will create for that process the environment variables with the same name of the parameters that were created in your YAML file. So even simple tests can have access to the parameters that are specified in the YAML file. Okay, any questions so far?
Sorry, you mentioned there is a remote execution.
Yes.
Is it something like Ansible?
Okay, question is there is a remote execution of Avocado, and is that something like Ansible? No, it's different. It's very different, actually. But what we have right now is a remote test runner. And if you specify in the Avocado command line that you are using a remote execution, you want a remote execution, then instead of the local test runner, we will call the remote test runner. And this remote test runner will connect to a remote machine. And the difference lives in the fact that you have to have Avocado installed in the remote machine. You have to have your tests available in the remote machine. We will execute everything remotely, collect the results, merge with the local job results, and show you the results. And it's not the same still. It's a remote execution, but the point here is that we trigger this remote process in the test runner selection phase. Because you created the remote execution in the command line, we identify that, and we say, oh, okay, so we have to use not the local test runner, but the remote one, and that triggers the process.
Does that mean the Avocado can handle like system reboot during the test?
Sorry?
So when the test machine rebooted, restarted,
Mm-hmm.
is it able to pick up from
No, because you are interrupting the job, yes. So you can write a test that waits for that, but Avocado itself will not handle that because we are waiting for that test to finish, and if you reboot the machine, the test will not pick up from where it stopped. Yes, interrupt. No, not right now. Yeah, the question is, can we run tests in parallel? No, right now we have only sequential tests. We have, I will talk about that, but we have some plans for this year to change some architecture of Avocado, some improvements that will eventually allow us to run tests in parallel, but right now they are sequential.
Question is very simple. So I'm seeing here so far the presentation. Nice presentation.
Thank you.
So all about unit test format. So my question is Avocado able to understand and run different types of tests? Like, let's say that the QE team has part of the test in Selenium, or part of the test in Bash script, or part of the test in something else.
Mm.
Or the test must be a unit test. Do you get my question?
Yes, the question is the test must be using Avocado API, or it can be anything else like a Bash script or anything else. As I said before, all those tests that are not using Avocado API, we call it simple tests, and it will be just executed as is. We will not load the test class, analyze what's in there, make the Avocado test API available for it, but still we will run it and collect the test, the exit code, see if it worked or not, and show the results with our result format, so it's perfectly possible to execute anything from Avocado.
I'm so sorry. I'm not sure if I follow the answer. So if that QB team has part of the test, let's say in Selenium, so that means that Avocado is going to understand that one as a symbol, and then you'll be able to execute.
You can execute it as it was any binary. We will not understand the API used inside that test, but we can run it if it's executable. You can also inform an external runner like /bin/bash to execute your test with that. Yeah, and if you have let's say, something else that understands that test, you can use it as external test runner. Okay. Thank you. Okay, let's move on. But if you are using the test API, what you get from it? If you are using the Avocado, the Python API to write your tests, what are the advantages? Here's some examples of some features from the test API. We have, apart from the params that are accessible from the test, you have also some logging facilities or capabilities to log your test as it's moving on. So you can even tweak the user interface to show a different UI based on the test that you are executing. So you can disappear with the default user interface and show only your log messages that are specified inside your test, or you can merge them together and show both the user interface and the log message that you are creating inside your test. We have some special methods to tell Avocado that that test actually failed. So you can, inside your test function, inside your test method, you can call the self.fail if a given condition is reached. So Avocado will know from that point that that test was failed. It will not appear as pass. It will be reported as failed in every result format. The same for error. We have the self.skip, so you can skip that test from to be executed. We have this utility here called fetch asset, which helps you to get assets from the network, from the internet, some URL, some local NFS, some local network NFS sharing. You can get the assets from there. We even cache those assets, so you don't have to download it every time you are executing your task. If you put an expire time for it, we will re-download it if it's expired already. We have some references for some important directories that are available for Avocado during the execution. And we have also the runner queue, so we can communicate all the way from the test directly to the test runner through the runner queue. So we can, for example, tell to the test runner to, after that test executed, you please execute or call a given function that's defined somewhere else. So those are just some features that are available in the test API. So you can benefit from them if using the API. Okay, and how the job back there will know the results from the tests that are executed by the test runner. How do we propagate the results back up? If they are simple tests, it's all about receiving the exit code 0, and then we consider that that test actually passed. If it's instrumented test, then we check if there's no exception in setup phase, there's no exception in test method execution, there's no exception in tear down phase, then we consider that that test passed. This information, this final test status is returned to the test runner. It will receive the test status, and the test runner will create this set of failures that might happen in the test during the execution, and will inform back to the job only this summary of what happened in the test. So the job actually gets a summary from the runner, and this is how the summary looks like for this job, for instance. We have here a pass test, a fail test, a /bin/false, sleep 10 minutes, and we have a job timeout of 5 seconds. So these 3 tests up here, they will be executed within 5 seconds, but this sleep 10 minutes test will be interrupted because it takes 10 minutes, and we only have 5 seconds. So these 2 guys here are contributing for the test runner to inform job that something failed here. This guy here, as it will be the main responsible for the job to be interrupted, it will be reported as interrupted, and it will contribute for this information here. I'm just making it explicit that we are using a set because it means that different jobs that are failing for the test runner, they will result only in this summary, only one flag fail for the job. And then Avocado, with this information here, Avocado knows that it has to exit with the exit code 9. This exit code 9, it means we have some tests that failed, and we have a job interruption because of this job timeout. So our exit code, it's horrible. You can have more information than just paste or fail from the exit code. Okay, and final layer here are the results format. We have a result class. We have a bunch of plugins, so you can create your results in different formats depending on how you are going to integrate your your job with your CI tools or anything else you want. Some of those plugins, they will wait for the final job results to generate the report in that format and provide you that report because they cannot be interactive. They have to be created all at once, so you have to wait a little bit because the job is execution, and then you will receive the final result in that format. And depending on the plugin, like the tab plugin, you can see the results coming from the job as the tests are going. This is just a screenshot of an integration between Avocado and Jenkins. Here we are propagating the XUnit results from the job back to Jenkins, so Jenkins can show you all the tests that failed. You can have the backtrace here, the details. We can see that 392 tests were executed, 5 failures, and here the details. And you are looking for these details in the Jenkins job itself. You don't have to go through the Avocado logs because we are propagating back the XUnit results here. Okay, so what's next? We had some meetings already this year to define the future of Avocado, and we have a strong focus this year in this job API, so you will be able to create your jobs not only by the command line, but you can create your jobs like using a Python API to define, to create, to load your test runner, load your resolvers and everything. So this will unlock a lot of power from Avocado that we know Avocado already has inside, but it will be unlocked with this job API. Also, variant enhancements. This is ongoing work as well, and also remote enhancements. Actually, something that's, that every time comes up is the multi-host test executions, and this is something that is under heavy work and review right now. Anyway, if there is something that interests you, you can go to our Trello board and vote for your features. You can report or request stuff in GitHub as well. We have this release management information right now, current version 45. We have tarballs and RPMs for Fedora and enterprise Linux. We have a long-term supported version, which is the 36.3. It's supported for 18 months. New LTS every year or so. We are Fedora package already. In Fedora, you can install Avocado by running dnf install Python 2 Avocado. The version there is 43. And pip, we have always the Avocado framework package with the very current version. Three weeks release cycle. We are 3 full-time engineers at Red Hat. 2 of them are right there. And we have contributions. This is from Gitlog. We have contributions from all those domains here already, and I would like to see more domains contributing to the project as well. And some community information, and that's it. If you have questions, that's the time.
One question about, do you have any plan to set up like Avocado as a service to run as a unit somewhere else, and people could send out and test through API service and could be run and kind of like integrate Jenkins install together?
Okay. Question is if we have any plans to run Avocado as a daemon remotely, and then you can like trigger jobs remotely from that point. We never discussed that as a feature to be implemented. Actually, I have never seen requests on these regards, but yeah, we would happily discuss that and consider if it would be something feasible and also useful according to the project's directions, but no, we don't have anything in that regard. Okay, thank you. Anything else?
You described parallel building at this position. There are any libraries to use that parallel, for example,
Library to use. Okay. The question is, I showed some example on kernel building tests, and if we have some library to use that in a virtual machine. No, we don't have such thing. That library is from Avocado utils, and it's something to make easier to download, configure, and build your kernel without having to go outside your test. But other than that, after build, the goal would be to use it, to test it some way, but we don't have more than that. After kernel is ready and built, the library ends there. But I mean, you always can go there and make it better, right?
So there's a related project, some other institutes, and you can actually combine some of these libraries from Avocado and how you see eventually matching like different small commands, usually based on dimensions, or if you install anything before you actually play it. So you change the parameters.
Okay, thank you. Anything else?
One more.
Please.
Does Avocado take care about the setup and preparation of the client, whatever the task will be executed? Like it's part of the work. I have seen this.
Yeah.
That they need a little bit more context.
Yeah.
I've seen that doing things that they need to prepare the environments that they want to test before actually to start execution of the test. So install a product, set up the product, do something else. So does Avocado take care of all of this too?
Oh, this is the Avocado takes care from. Sorry, the question is: does Avocado take care on the target environment preparation before running the test? No, it doesn't. Avocado will be started in an environment that it's expected to be ready for the Avocado execution already. So you have to prepare the environment. Of course, as we are discussing the multi-host implementation and how a test that's local will be sent over a network to a remote, and what will be ready in this remote system to execute that test is under discussion right now. But what we have right now is when you define the test locally and say that will be executed remotely, we expect the remote host to be ready for that test execution.
Then you explain some of your tests about remote execution. That's one. So you explain that the Avocado needs an agent to do the remote execution, right?
Not remotely. We have a different module, a different runner class called remote, and this different runner class will connect the remote host using SSH, and it expects Avocado to be installed remotely, and it expects the test, the file, the module itself to be available remotely as well, and then it can be executed remotely, and we collect the results back.
My last question was just would like to understand a little bit more about this. So to install the Avocado in that machine that my tests are, and it will be executed remotely. Have an idea how many packages we're talking about that Avocado depends on? I'm talking about a physical test.
Yeah, we have some Python dependencies, but other than that, we have Fabric.
So the basic runtime necessary for Python actually for Avocado, it's actually describing the setup of the Wi-Fi, which is not the basic Avocado for running. You can even like declare, suppose you're a Python project itself, and you're writing tests using the Avocado API, and you're provisioning, you're saying your source code should be tested on another machine. You can just put a description on your Python requirements and say, oh, we could do Avocado for you. You should have like already installed like a setup tool,
Yeah, the
it's basically CDOR, which we use for the coding system that we have. So most of it should be optional. So we can use the same OpenStack framework for Linux. So that is like 4.
Okay. So yeah, it's quite easy to get the system ready. Okay, that's it. Something else? Okay. Thank you, guys.